IIB, we're going to look at 20F, which is variance and standard deviation. And just taking a look at what these mean in general, they basically give you an average deviation of each of your data values from the mean. So it does take into account every single data value that you collect or that you're looking at. And it just looks on average, if you look at the middle or your median, your mean, if you look at your average right in the middle, how far does every value deviate from that mean? All right, so let's just take a look at 3 different classes. And these are 3 very different classes. And so far what we've talked about is mean and median. And when you're looking at your mean, yes, it takes into account all of your values. However, if we look at this set of values, so 7, 7, 7, 7, 7, if we added all these up, divided by 5 total values, we would have an average of 7, and our median would also be 7. If we look at class 2, I've added all of these up, set up a list in my calculator, and here we go to menu, we'll go to statistics, stat calculations, 1 variable, and we call this one X. And here we have our mean as well as 7. And if we take a look, our median would also be 7. Let's do the same thing now for our class 3. So 3, 5, 7, 9, 11. That's my second spreadsheet here. And I'm going to go to an empty cell, again, menu, statistics, stat calculations, 1 variable, and I've called these Y. And my mean is also 7. And of course, my median is 7 as well. So if I look at these 3 different sets of values, my mean and my median are both 7. So it doesn't give me a whole lot to actually analyze since the data is very different, but my mean and my median are exactly the same. So we do need some different data to take into account. Well, they might be the same distance away from the mean on both sides, so it might be a balanced, kind of a symmetrical set of data. However, or it might be skewed, we're not sure, but for symmetrical data, we need some other things to actually analyze. So we go into variance and we go into standard deviation. Now, most of the time, you guys will be using your calculator to do this. However, we're going to go through, this is investigation 3 on page 532, and we'll just go through kind of where this formula for standard deviation comes from. If we want to look at how far every single value deviates from the mean, we're going to subtract the mean from each data value. So 7 minus 7. So all of these are going to wind up being 0. Because your deviations could wind up being negative, we're also going to square those values, which again for this one would be 0. So this one maybe not so helpful to look at variance and standard deviation because there is none. So let's take a look at the second class. X minus 7, so you're going to wind up with -2, -1, 0, 1, and 2. If I square all those values, we get 4, 1, 0, 1, and 4. We add that together, we get a total of 10. So what the variance does is it takes that sum of all of our X deviations, so X minus X bar, mean. We take all those deviations, we square them, we add them together. I got a total of 10, and then I divide by the 5 values that I have, and I get a variance of 2. Now, since I squared all of my values, it does take me away from what my values originally were close to. So what were they actually worth in the beginning? So I'm going to take away that square by taking the square root of the variance, and that gives me my standard deviation. So it standardizes my values so that I can talk about it a little bit more realistically. So standard deviation is basically saying that square root of 2 is a little bit over 1. So all of my values are deviating from the mean by a little bit over 1 on average. All right, so that's what that's telling me for class 2. Class 3 will do the same thing. So 3 minus 7 will wind up with -4, -2, 0, 2, and 4. We'll square those. And then we'll wind up adding, so 16 and 16 is 32, plus another 8, so we'll get a 40 total. Divided by, we have 5 values again. So our variance here is 8. Our standard deviation is going to be the square root of 8. So square root of 8, around 2.5, a little over. So we're going to wind up taking a look here, and on average, my values will deviate from the mean by square root of 8. All right, so these two values start to give us a little bit more information. They start to give us a little bit better idea of the spread of our data, and then we can analyze them a little bit further. So in your textbook, you'll notice that your variance is represented as s squared. Because you have squared values added together, we have not taken the square root yet, and dividing by how many values you have. When you get your standard deviation is when we take the square root, so it's just the s for standard deviation, and you wind up taking the square root of the variance. So a few things to consider about why we even study standard deviation. If your standard deviation is small, then what is that going to tell you about your data? All right, so all of our data will be very close if we have a small standard deviation, so we have a small spread. Whereas if our standard deviation is large, we'll have a little bit larger spread. Our standard deviation is also non-resistant. In other words, it is affected by outliers. So when you're looking at a box and whisker plot, we take out the outliers, and only certain values are used. However, with standard deviation, every single value is accounted for, and it can be affected by outliers. So therefore, we do need to just remember that when we're analyzing our data. It is definitely more useful for symmetrical data, so data that's symmetrically distributed. And IQR is better for skewed data because it gives you a better idea of what direction is it skewed, positive, negative, where is the quartile, where's the second quartile, third quartile. So we want to know what we should use in what case. All right, so this is a very symmetrical set of data. This one isn't bad, but we definitely have a little bit of a peak right here, so that might skew our data slightly as well. All right, so just think about if you had taken the standard deviation for these two sets of data or the IQR, what do you think, what information would it give you about each of these? So your textbook does mention the notation that we're going to use. So this box right here is extremely important, just to note what notation is used in what situation. Right now, as an IB student, we always talk about, IB questions will always assume that you guys have the entire population. Therefore, we are going to focus on the notation that's in this column. However, your calculator does give you X with the bar on top, and that is your mean. Technically, that's used for a sample, and there is, because you take a sample and there's possible error because you're making a judgment on a population based on a sample, we do wind up getting slightly different values for the variance and standard deviation. However, again, in IB, we always will focus on the fact that we always assume we have the entire population, so we are going to be assuming that we have the mean, the accurate mean, and the standard deviation to analyze. So you guys will be using mu, all right? Mu, which is this nice fancy M for mean, or X with the bar on top for mean, which is how your calculator shows it to you. If you see the S squared for standard deviation, or for variance, excuse me, that is technically a sample. We use little sigma. And also for standard deviation, you see an S if it's a sample, but we're going to use the little sigma again. So in our calculator, the only difference is that you would divide by n minus 1 instead of just n. So if you look back at your formula, to account for a sample, this would be n minus 1 instead of just n, and then it accounts for a slight error. However, again, for us, we're just going to use this one, which is a standard deviation that's based on an entire group or a population. So if you continue with statistics in college or university, you'll wind up looking into that a little bit more. So again, sample is the S, the population is little sigma. This is the one that we want. So when we go to our calculator, and I've already put this one in, 1357, again, I'm going to go through this again so we remember, stat, calculations, one variable. This is my set of data called Z. I want to look at my mean is 5, and my standard deviation, this is the one that I want to focus on, the 2.8, and we'll round that off to 3. Okay, and my standard deviation was 5. So just double check that we are looking in the right place. We do not want the S1, we want the little sigma. And last but not least, in 20F.3, we'll look at some grouped data. So even though we'll use our calculator for this as well, just note the difference in the formula for standard deviation. Since we have frequency now, if we group our data, we'll have a frequency for each of our intervals, right? So, or for this example, for each of our scores. So when you wind up finding your deviations and we square them and we add them together, before we add them together, we want to multiply the square deviation by how many of those we have. So we multiply that by the frequency, just as we divide by the frequency of our total frequency, which is adding them all up. So our formula changes just slightly. For our calculator, we'll wind up using two lists. So again, we'll use our X list for our data values. We'll put a frequency list in, and then we can actually find the standard deviation accurately as well, since the calculator has this formula stored and it will find it for us very nicely. So let's just take a look at how this works. We have our X values, we have our frequency, we have our frequency times our X values, how many total we actually have. And we are going to find each of the deviations, square them, multiply them by the frequency, and add them together. All right, so that's the only difference, is it changes that numerator. Our totals for the denominator, we have 10 total values, and then we wind up finding our standard deviation. All right, for the mean, we have to take our frequency times our X values to figure out what our total is. So that would be this 30, our frequency times X, and divide by how many values we actually have, which is the 10. All right, so just taking a look at how those are calculated when we actually have frequency, and if we had to do this by hand. All right, guys, we're going to start here. We'll pick up with some examples in class. Otherwise, have a good night.